this notation always confused me. The first step is to understand R of t. And R of t is the position vector is a function of time. So it's going to be x of t, y of t, z of t. It tells you where a particle is at any given time. Now, f of r is typically a vector field. It assigns a vector to every point in space. So electromagnetism, gravity, etc. So this is going to be f of x, y, z making it f of r of t now just replaces this with functions of time, which doesn't, it just makes these functions of time now instead of just values in space. So for an example, if we have f equal to x squared, y squared, x squared, y squared, z. Let's do that. And we have r equal to cosine t, sine of t, and t. F of r of t would be f of cosine of t. Let's make that actually look like a cosine of t. So then, I don't fully understand how this multiplication works, but it's going to be cosine squared of t, sine squared of t, and then finally just t. So F is going to be the force field, or the force function. And then r is going to be the path that the particle is moving along. So basically what we're doing, we have f of r, we have an input vector, and then the output is a vector. It's different than, say, u of r, which would be an input is a vector, but the output is a scalar. So when you have something like this, you're going to have something like that. When you have like this, when you have f of r, you're going to have something like this. The components are not the entire thing. Well, I mean they are, but each component has its own scalar multiple, I guess. Something like that. Those are the main differences of the two, and I was always like really confused. I'm like, what the heck does this mean? How can we have a vector who's a vector inside of a vector? And I was just really confused, but it's just the function.